We're now going to solve an applied problem using 3 variables and 3 equations, and the one we're going to look at is a CAT scan. And so the idea is that we send a beam through some tissue, and it tells back how many units got through. So it hits the tissue, and you've got your bone, and you've got muscle, and different things, and this beam goes through it, and it records. And you do this in different cells around the body, and as those cells come into play, you can determine what the substance was. And so we're going to look at a particular patient and the information about that. So we're going to put 3 beams through these 3 cells, A, B, and C, and then we're going to compare that to this table. So first we're going to use this information right here to solve to set up our problem, and then we're going to solve it, and then we'll come back and compare it to our table. So the first thing that we're going to do is recognize that each beam is an equation. So we're going to get the equation for beam 1. We get the equation that A plus B is equal to 0.65. For 2, we're going to get A plus C is 0.7. And for 3, we're going to get B plus C is 0.55. And so we're going to solve this first, and then we'll come back to that table again in just a moment. So we already have an A here. We now need to get rid of this A, so we're going to take 2 minus 1. The A is missing from this, so we don't need to modify 3 at all. So we're going to get minus A, minus B, and minus 0.65. So now I get the equation A plus B equals 0.65. Minus B plus C is 0.05. And B plus C is 0.55. Well, let's swap these 2 rows. Let's make 2 and 3 trade places. I'm going to do that because I want to keep the positive 1. So A plus B stays the same. I could have changed the signs as well, the first one, but I'd rather swap them. And minus B plus C equals 0.05. We come back in and we say, now let's just take 2 and add it to 3, and that'll be stored in 3. We stored in 2. So we need just a little bit more room, and then we're going to be just about done with this problem. So A plus B is 0.65, B plus C is 0.55, and when we add these together, we get 2C equals 0.6. So if 2C equals 0.60, that means C is 0.30. So then B plus 0.30 is equal to 0.55. Subtract that over. B is equal to 0.25. So A plus 0.25 is equal to 0.65. This means A is 0.4. So A is 0.40. B is 0.25, and C is 0.3. So we come back up, and we say A is 0.40, B is 0.25, and C is 0.30. Notice that still works. These 2 we already checked, but 0.4 plus 0.3 is 0.7, so this makes everything true. We come into our table. We find here the only thing that A could, it might be tumorous tissue, but chances are better that it's A is bone. B is 0.25, so that looks like healthy tissue. And 0.3 is right here, smack dab in the middle, so it looks like we've got a tumor in C. So that's how we can use this to solve these problems. And now that we've solved them, we know what to do, and we know what to tell her, and we know what the doctor can start looking at prescriptions and different things to try and deal with this tumorous growth.